This is a Carboline production.
Owners of elevated water storage tanks have lots of top coat options available to them. Whether their primary concern is aesthetics and branding, or long-lived performance, or budget, they can find what they need. But in terms of visual appeal and corrosion protection performance, one resin technology, fluoroethylene vinyl ether, does stand head and shoulders above the rest. Accordingly, so does its price tag. So today, fluoropolymer topcoats take center stage. What are they? Why do they work so well? Why are they expensive? And just how good is that ROI? That's next on the Red Bucket. It's very satisfying when a topic of discussion consists of the overlapping expertise of not one but two voices that you've heard here recently. So I am thrilled to welcome back Jeremy Sukola and Kristen Blankenship. Jeremy is the Vice President of Prime Resins and Carboline's Market Manager for Water and Wastewater, longest job title ever. And Kristen is Carboline's Product Line Manager for Atmospheric Coatings. Thank you both for being here today.
Thank you.
Thank you, Toby.
And the subject here's fluoropolymer topcoats. There's quite a bit of an evolution which has taken place. With that in mind, thinking about fluoropolymer topcoats for water tanks, this isn't really new, but it is an evolution from someplace in the past to the present. And I wonder if you can walk us through briefly, where did we start with fluoropolymers? How have we moved? And how did we get where we are today?
Absolutely. And I'll go over my very brief understanding of the history of fluoropolymers, but we'll always cede the conversation over to our expert on the topic, Kristen, when we start talking about molecules and chemistry. So basically, we're looking at fluoropolymer technology being around prior to World War II with the accidental discovery by DuPont of PTFE, better known as Teflon, polytetrafluoroethylene. Really, the idea behind this product was its nonstick capabilities, its chemical resistance, but PTFE in and of itself, not really for coatings, especially 75 years ago. So fast forward 30 years or so, and now we're talking about an evolution in that technology, PVDF, or polyvinylidene fluoride. Really what you have here is you've got like I said, an evolution in this technology for coatings that were primarily used for coil coating, architectural type applications. These types of materials require baking in the oven. They're known by some pretty common trade names, Kynar, Hylar. But again, we're talking about mid to late 60s here. You start moving into the 1990s and 2000s, though, and we've got another evolution of the fluoropolymer technology in the FEVE resins, the fluoroethylene vinyl ether resins, where we're really looking at field applied fluoropolymer top coats. And the one thing that stayed the same throughout all these evolutions of the fluoropolymer top coat really is its UV stability. And its ability to protect against degradation caused by ultraviolet light, in addition to its chemical resistance, and some things outside of the coatings industry that it provides in the electrical world. So that's a real brief history of how the coatings industry really started to adopt fluoropolymer technology, really beginning in the 1960s, but through field application in the mid to late 90s and onward.
Kristen, as I ask this question about what makes a fluoropolymer, or what makes a fluorocoating, let's talk about what is the experience that you have that is the source of that knowledge on your end.
The world of fluorochemistry is very vast and broad, even though it relies solely on the fact that there's one element included in all of it, and that's why it's fluoropolymer, and that's fluorine. I did work previously for a company that manufactures fluoroethylene vinyl ether resins. And as Jeremy noted, these types of fluoropolymers really were relegated to a factory or shop environment because, as I mentioned earlier, fluorine doesn't like to play nice in the sandbox with other elements, maybe put it that way. Um, and so it's very hard to get it to do much. It's hard to get it to react with other things. And then when it does react with something, it's hard to break it apart. And so usually most materials that use fluorine require some type of high heat. And so we talked about Teflon, PTFE, those types of materials usually require 800 degrees Fahrenheit to actually form a film. PVDF, polyvinylidene fluoride, as Jeremy noted, was a breakthrough because it only needed 450 degrees Fahrenheit. But you can imagine you're still in a factory environment. So what happened in the 80s, over in Japan actually, was the development of a material called fluoroethylene vinyl ether. This was unique in that it actually allowed for film formation at room temperature. It also, the molecule allows for the addition of what we call a functional group. So it's basically something that likes to react with something else. And in our world of water tanks and coatings for water tanks, we like something called a hydroxyl group. And so that group is put on the backbone of this FEVE resin. And guess what? It can react with the reactant that forms a urethane. So you went from having urethanes, aliphatic urethanes that weather really well, to a fluorinated urethane that weathers, frankly, better than probably any other type of material that's out there. These materials rely on a carbon-fluorine bond. That bond energy is stronger than what comes from the sun. And so it just simply doesn't break down. There's other components in it because it is a fluorourethane that do break down over time, but because a large portion of it is that carbon-fluorine bond, it really has a very, very, very slow rate of degradation. The breakthrough with this technology was that you could apply it in the field, outside, and it dried. So guess what? That's great for an elevated water tank. And the other thing it really helps, which is really great for elevated water tanks, is maintaining bright, shiny finishes with high gloss. That was another breakthrough with this resin chemistry, is that it actually gave you high gloss. PVDF really is more of a kind of satin matte finish. So as Jeremy noted, for coil coating and for facades in the architectural space, high gloss is usually not necessarily the best thing. We don't want to blind pilots in the sky and melt asphalt on the ground. So it just kind of worked out well that these materials were developed, and they really work well on elevated water tanks and have been used in that space for decades now.
And while Kristen has decades of experience with formulating FEVE, I spent the last 2 hours before this podcast learning how to say fluoroethylene vinyl ether, just to not embarrass myself.
That one rolled off the tongue really, really well.
I've been practicing hard.
Well, you brought up, Kristen, the use of this resin technology within coatings that are applied on water tanks. Whatever is the coating that is applied to a tank isn't the only one. It exists in a coating system. And so whichever of you wants to take this can take this, but let's talk about the role of a fluoropolymer finish coat within the context of the system of which it is a part.
Yeah, no doubt. Fluoropolymers excel as top coats, right? As far as UV protection, color and gloss retention, there are none better. However, fluoropolymers only work when we look at something, let's say like a water tank, they only work because they are part of a full system, right? So coating systems made up of primers, one or more intermediate coats, top coats. Okay, so we use the primer. Obviously, it promotes provides adhesion to whatever substrate that you're working on. In this case, we're obviously talking about steel. So depending on the type of primer that you use, you can have some other forms of protection. With zinc primers, you get galvanic protection. With epoxy primers, you get barrier protection. Or if you combine, moisture cured urethane or epoxy resins with zincs, you get the benefit of both. Intermediate layers, Typically on tanks like this, intermediate layers are usually more of the aliphatic polyurethane type. So we can add some build to the system. We can add some additional chemical resistance, but it's not to say that an intermediate coat cannot be an epoxy. Again, another barrier coat to add some mils to the system to provide that enhanced barrier protection with a normal aliphatic polyurethane, and then obviously a top coat. So the fluoropolymer top coat providing the UV resistance, the excellent color and gloss retention, in addition to the chemical resistance that this resin in this system provides. So it's like building a house. Use your primers as your foundation. You're using your intermediate coat or coats as the framing of the house. And the fluoropolymer would be like the weather resistant siding in the roof on top of the structure, protecting it, giving it that ultimate protection.
If I could jump in here for just a second, because this is a really good point that you're making, Jeremy. The ability of that top coat, or as you mentioned, weather resistant siding, it's the shell of the building, right? It really is important to have something that withstands the effects of UV light, moisture, and rain for a really long time, because what'll end up happening is typically it's a process called photochemical degradation. And what'll happen with, non-fluorinated top coats is you'll start to see some breakdown at the molecular level. You can't, I say see, you won't see it. That's the whole idea, right? The only thing that you will see is usually a loss in gloss over time. And so many times in the industry and the conversations I've had, there's this idea of separating, oh, well, I don't care about color and gloss, right? I care about corrosion. And the reality is they're not separate. If gloss is starting to drop, you're actually starting to see that coating film break down at the molecular level. Again, you can't really see the bonds breaking, but the effect of that is that you're getting micro cracks and voids within that coating film. And what does that do? Well, it allows moisture and salt, and then over time, UV light to get down to that mid coat, which in a lot of cases is an epoxy. So the more UV light that hits that epoxy, that starts breaking down. And then eventually you'll get that moisture into your primer, and you'll start going through the zinc if you're using a zinc-rich primer. So the shell or the top coat is really more than just aesthetics. It really is a protective layer that protects all the layers underneath and allows them to do that job. Just like you mentioned with the weather-resistant siding on the house.
If one was to compare performance of a fluoropolymer top coat in a system versus other weatherable urethanes in a system, my question was going to be, is there a pecking order in terms of performance? It sounds like that's not really a question, though.
No. At the very, very, very top of that order are fluoropolymers for sure. Typically, when we're looking at color and gloss retention, UV protection on something like an elevated water storage tank, it really runs the gamut. Basically, you're starting with real super old school alkyds. Then you can move into some acrylic-based formulas. Could be water-based, could be urethanes. Then we move into the aliphatic urethanes, which really also runs the gamut of color and gloss retention and UV protection. We have some real bargain basement aliphatic urethanes all the way up to, super advanced, pretty good performing aliphatic urethanes. You've also got polysiloxane technologies, which do a really good job of color gloss retention, chemical resistance, UV protection, some higher film build. But yeah, absolutely at the top of the order would be fluoropolymer top coats. Would you agree with that, Kristen?
Yes. The one thing to keep in mind always is formulation, right? And I think in the industry that we're in, there's been a lot of effort to be sure that these fluoropolymers are formulated properly. But yes, a properly formulated fluoropolymer paint is going to last longer than really any other system that's organic in nature that I can think of.
So with these pretty impressive performance characteristics that you've both noted, and the discussion of what's happening at the molecular level with such strong carbon-fluorine bonds, on the one hand, it sounds like pretty much any argument for fluoropolymer top coats is a good argument. but not every problem is solved by fluoropolymer top coats. So I wonder when you don't need this. What are the situations, Jeremy, where if you have the buffet in front of you, the thing you reach for is not the fluoropolymer?
I would say first and foremost, upfront cost of the technology is something that has to be weighed on a per project basis. And I say it that way, upfront cost, because obviously fluoropolymers last quite a bit longer than competing technologies. So over the life cycle of the structure and of the coating system, it does pay back, but that upfront cost sometimes it's outside of the budget of a city or a municipality if they're repainting an elevated water tank or painting a new build tank. We've got areas of the country that perhaps we don't have UV degradation as bad as we do in other parts of the country. I today am recording this in my office in Atlanta. So in the Southeast and the Gulf area, we get a little bit more sunshine down here than certain parts of the country do. I'm originally from Seattle. I could see where we would use quite a bit more fluoropolymer here for UV degradation in Atlanta than we would in Seattle. So UV exposure is a consideration, but other technologies exist in that space too. The standard aliphatic polyurethanes. If we're in an area where perhaps extreme color and gloss retention isn't needed, that aesthetic portion isn't our primary goal, chemical resistance, film build, things like that, really good polysiloxane will fit in there. So we always have to match the solution to the environment and to the project. So those are just a few instances where a fluoropolymer may not be needed.
And I'm sure listeners, just as I, have been building a picture in their head of, we're talking a lot about these elevated water storage tanks. A water tower in your hometown, if it's going to have fluoropolymer top coat as part of its system, it's not necessarily the case that it'll always be the entire surface area of
Correct.
that structure.
Yeah. Some tanks are monotone colors. It's just one color, top to bottom. Sometimes they use standard urethane. Sometimes they'll paint the entire tank with a fluoropolymer, just that single color. A lot of times cities will use these elevated water storage tanks as logos for their city, right? There's a lot of civic pride in perhaps the high school or local business that's really big in the community. So a lot of times the municipal owners will decide to paint very, very elaborate logos on these elevated water tanks. And it's not to say that standard urethanes could not do the job, but because we look at these logos, for bright, vibrant colors, and we really want them to stand out, a lot of times we're using fluoropolymers for these logos. And these logos can get extremely intricate. There's some fantastic tanks that exist out in the world that have these wonderful logos and themes painted on them. Eric Henn is a painter that paints these wonderful logos on water tanks and primarily uses fluoropolymer technology just because of how bright and vibrant it is. So it can be an entire tank, or it can be just logos themselves. So we're talking again about going from maybe 8 to 12 years with a standard urethane to 15 to 20 years on the use of a fluoropolymer top coat. So upfront costs a little bit more, but because we're extending that service life, we have less maintenance. It really does pay for itself in the long run.
Kristen, can you talk about application properties of fluoropolymers? Because when Jeremy brings up logos, lettering, in some cases very intricate designs, we start to walk away from this image of somebody on a scaffold or hanging from a rope with a spray gun and just doing the entire area very quickly. There's some craftsmanship involved here. And I guess what should we be saying about application properties for fluoropolymer top coats?
This question came up quite a lot in my previous life, working with these materials and trying to educate the market and our customers about how they were used. And of course, the biggest misconception was that because they were specialty because they did special things and because they were this really long chemical name that nobody could pronounce except Jeremy. But that they must have some special way of being applied. They must look different in the bucket. They must feel different when you apply it. And the reality is, they're very similar to a standard 2-component urethane system. And with that being said, of course, you can formulate urethanes to be spray applied, airless spray, conventional spray. You can also formulate them to be roller applied and brush applied. So the resins themselves can be formulated with different additives and different thinners that allow for really nice brush and roll application. So that's where you really have to work with your supplier and the manufacturer and understand the limits of the paint itself. So it all comes down to the formulating.
We talked about a cost component to all of this and the calculations that an owner or that a specifier is going to do, the upfront cost versus the, how long does it take that cost to pay off? But Kristen, the sticker shock does come from somewhere. Where does it come from?
It really is the unique material. It's novel chemistry. That's why there really is only one supplier globally with a true fluoroethylene vinyl ether system or resin system. And those unique raw materials, they oftentimes come with the price. And we just haven't really seen anybody come in and crack the code on how to make it. There's been some attempts in the market, but nobody's really been successful. You can imagine if you have a raw material that is going to withstand degradation for decades, you have to be sure that you manufacture it consistently with quality in mind and use raw materials that are going to give you that end product every single time to deliver. And so there is a price tag that comes with that.
It feels to me like, especially with there being so few suppliers in the world that can supply the world capably, it's sort of the opposite of a situation where you've cornered the market on like toasters, and then it doesn't matter if the toaster's good or not. It's just you sell all of them to, there's no competition. But in this case, I think the stakes are a little bit higher. So it would seem to me that that emphasis on quality, they can't have their guard down. If the resin, they invented something really great, it has to stay great. It has to be great the entire time, because it's not like there is a easily accessible substitute.
Absolutely.
And Toby, it really comes down to, like Kristen stated, the performance, because what the performance ultimately equals is a lower total life cycle cost, right? If we're paying to paint, for instance, an elevated water storage tank today with a product that costs X amount of money, and we know that we're going to get 20 years out of that before we need to do some maintenance painting on it, versus perhaps a standard urethane system that still provides very good protection for 8 to 12 years before it needs some maintenance or even a total redo. The cost of the labor and the scaffolding, the mobilization, the coatings, 8 to 10 years from now, it more than makes up for that upfront cost for this technology. We have to look at these coating systems as assets that, provide that protection, and the upfront cost of this technology more than pays for itself in the long run.
What else does the owner need to think about, right? There's every owner is different and their level of knowledge is going to be different. But if you were to compare what the average owner knows today about this technology against what you wish they knew, what would that comparison be?
Well, I think the owners have a pretty good understanding of what the value of the technology is, right? And that's really what we always strive to do. That goes outside of fluoropolymers, right? If we're trying to help an owner choose a secondary containment or a primary lining system, we always want to make sure that they have an understanding of what that upfront cost will eventually get them. And it's always about total life cycle costs for the structure. When we talk about, especially municipalities that have to stretch every single dollar they get, this is what we want owners and specifiers to know. about this technology. I'm pretty confident that there's a pretty good understanding that with the application of this top coat to the rest of your system versus, you can't see my air quotes, but a standard top coat, aliphatic urethane. Here is what you can expect out of that system, right? Superior color and gloss, very, very good UV protection for the tank. Again, the coating system itself is an asset. And I think that the fluoropolymer top coat helps protect that entire asset. So that's the main thing that we want the owners to understand is, that little additional upfront cost really does lower the total life cycle cost of this system and that structure.
How about human and environmental health impacts, Kristen? Is there cause for concern over the use of fluoropolymer materials for water tank top coats?
So it's an interesting question, because as a human on the planet Earth and someone who consumes media, I know that I have read about something called forever chemicals. I've read a phrase called PFAS, and generally what that refers to is something that by definition may include the very specific FEVE resin chemistry. But again, that's only by definition. Um, I actually have written, there was a chapter in a book that was referenced in some papers at some industry shows that have been cited in some of the industry response to this idea that fluoropolymer paints should be included in a class called PFAS. If you want to get into the weeds, and I can do that all day long, but I'll just let you know that it's really important to have conversations about these topics with knowledgeable people in the space. As we talked about previously, FEVE resins are a very niche resin chemistry that does something phenomenal. And that's why a company still makes them, because there's still demand, because they make these elevated water tanks beautiful for decades, right? So there's a reason that they're around. But as I said, these are very specialized materials. And so with the specialized material, there's usually a handful of people that may know the most intricate details of the chemistry. And those people aren't always seated at the table when these discussions about forever chemicals are going on. So what's been going on in the industry simply is that originally the idea of PFAS was really something where you had a fluorinated material that also was able to be soluble in water. Basically, it was a fluorinated soap, to make it easy. And so you can imagine if those fluorinated soaps get in water, they get in groundwater, and eventually they get in your body. And now you have carbon fluorine bonds going around in your body. And guess what? As we talked about earlier, fluorine is the most electronegative chemical on the periodic table, which basically means it doesn't like to play with other people and it likes to be left alone. And so there's been a concern, theoretically, that these materials will accumulate in your body because you can't break them down. And then the question is, well, then what? Well, that's the problem. We don't know that then what. So there's a lot of studies going on to understand the impacts to human health. And some studies have suggested that these materials do have a negative effect. And so it is very important to err on the side of caution. But it's also really important to think about throwing the baby out with the bathwater, so to speak. So the reality is that the FEVE resins that are used in these high-performing elevated water tanks, if it is FEVE resin, they are not formulated with actively PFAS materials. So there is a concern that, well, could they break down into those materials? Well, we don't know. And guess what? They don't really break down that much, right? That's the whole reason we use them. So I do know of one study that's been going on at the University of Toronto. I haven't seen any papers written. I actually spoke with the professor that was doing this study, and their idea was they were going to actually look at facades that were coated. I think Jeremy alluded to it earlier, coil coated and or extrusion. So those are spray coated, but those use either PVDF or FEVE. So they were going to look at the effect of, rain cycles over time on those coatings and see if any breakdown material could accumulate in the water, and if that breakdown material actually was, a PFAS type material. Well, I don't think those results are out, but that doesn't mean that these materials haven't been classified as PFAS, haven't been classified as these, the 9,000 chemicals that are forever chemicals. The reality is we haven't studied 9,000 chemicals to see if each one of those unique materials actually harms our health. So again, on the one hand, you want to be very cautious when it comes to human health, right? I think we've learned over the past decade or so that being cavalier with additives in our food, for example, can be a real problem, right? We maybe need to be scrutinize them a little bit more before we just throw in, red 40 into our kids' candy, right? But at the same time, while yes, your kid might be upset that the I don't know, the red hots aren't very bright red, right? Or the Fruit Loops. Um, what we're talking about here is that elevated water tank having to be repainted multiple times over the course of 60 years if you don't use a fluoropolymer. Well, what's the impact to the environment and frankly to human health of using those materials, manufacturing those materials, getting the feedstocks to manufacture them, the energy cost, the carbon footprint of making those materials and then applying them. And then, of course, the impact to the workers that are spraying those materials. So in this instance, it's really important that we do the science, we do the studies, and we get it right. Um, so I would say that at this point, the jury is still out on whether FEVE itself, which again is a fluoropolymer, it is inert, it's not soluble in water. You may see some water-based materials with FEVE or with PVDF. That doesn't mean that those materials are soluble in water. It just means they're suspended in water. So I'll catch that little note there if there's an eyebrow raised. But needless to say, this is an area of great concern and the research is ongoing, but we actually, as far as I know to date, haven't actually cracked the code and know the answer to whether or not FEVE resins contribute to the forever chemicals in our environment.
Jeremy, from a market regulatory perspective, how has the regulatory landscape kept pace or outpaced or lagged behind the pace of the science that Kristen just walked us through?
Well, I think it's keeping pace in that it's glacial. We are seeing regulations around the world that are changing. Here in the United States, perhaps we don't have quite the knee-jerk reaction to these technologies that we see in some parts of Europe, and I think that's okay. We do have customers that this is a concern for them. We do have customers that ask questions and bring this up, and we're as upfront and as honest as we can possibly be. In that, to Kristen's point, what she just said, that the science is ongoing, and the science will continue to be ongoing for years and years and decades. So from a regulatory standpoint, if there's concern on an owner's part about what the future might look like, there are options outside of fluoropolymers if that fits their needs, or like I said, if those concerns are persistent. We're going to continue at Carboline to follow the science as it comes out. We are stewards of the environment. Both Kristen and I, and yourself, Toby, we're parents. So, we think about all of these things. We keep them in mind. But again, we don't want to have a knee-jerk reaction to something that the science does not prove out. So from a regulatory standpoint, I think here in the United States, at least, a slow and steady pace. So I don't believe we'll see a knee-jerk reaction here on the coatings. That's not to say other parts of other industries that have fluoropolymer technologies, we won't see stricter regulations. But as far as the coatings world goes, for now, I think we're in good shape.
This seems like a pretty good place where we could put a stop to it. How would you wrap a bow around this, Jeremy?
I would say probably two or three things to take away from this. First, I think fluoropolymers are about looking ahead, right? We're investing now to reduce our costs and maintenance years down the road. I think for municipalities who are really focusing in on protecting our real super critical infrastructure, fluoropolymers do provide that peace of mind that their investment will last, right? We're paying a little bit more upfront for that longer overall life cycle. And it really isn't about paint, right? It is really about preserving these essential public assets. I live in a city and a town that's got water tanks all over the place, as I'm sure both of you do as well. So it is about preserving essential public assets, because we are stewards of these assets, and we have to give them to our kids when we're done. So it really is about preservation.
Well, with that in mind, we can move on to the 4 questions. Jeremy, having admitted he was scared to death of what I was about to confront you all with, so I've got 4 questions, and you each can answer each question. Are you ready?
Ready.
Ready.
It wouldn't be the 4 questions without a food question, so that's where I'm going to start. Some people include sugar in their recipe for spaghetti sauce. And my question is that sensible to you, or does that make them a monster?
Absolute anarchy. Absolute anarchy. Sugar and spaghetti sauce. I've never heard of such nonsense. Do you put sugar in your sauce, Kristen?
I would never put direct, just plain old sugar, but you can get sugar other ways, like caramelizing those onions.
I've heard too, people will grind up or shred their carrots like in a cheese grater and do it that way in a spaghetti sauce.
In spaghetti sauce? We might have to end this podcast right here, Toby.
Well, I'm not saying that I endorse sugar of any kind in spaghetti sauce. I think that's evil.
Agreed.
This one might be a little less controversial. Do you have a favorite body of water?
I actually do. So I grew up in the Seattle area. So the Puget Sound for me, that little inlet between the main part of Washington State and the big peninsulas that sticks up there, the Puget Sound. I grew up on that freezing cold body of water. And so I would say that, yeah, that's probably my go-to for a body of water.
I'm going to talk about the Atlantic Ocean. I got to experience the Atlantic from Brazil, which is a very different experience than the U.S. East Coast. And it was breathtaking to be up on these almost cliffs in South America and see the Atlantic that way. But when you're up high up on a cliff down in South America and going up these little roads in the mountains, it's a whole other experience. So we'll go with the Atlantic.
Question number 3. So this is the season for road trips. Summer is here. Do you have one from the past that sticks out in your memory, or do you have a dream road trip that you want to tick off the list?
I have a road trip that sticks out. About 15 years ago, I had to actually drive a car from my house outside of Atlanta back to where I used to live, just outside of Seattle. And I drove straight through without stop from Atlanta to Seattle. This was before GPS, cell phones, and all of that. So I had a big Rand McNally road atlas, lots of coffee, and 52 hours of straight driving.
And how old were you again, Jeremy?
15 years ago, so I would have been 12 years old.
Wow, that's impressive.
I was a younger man for sure.
I don't think I have one that rivals that, but I do. I cannot wait for the day that I can take my 4 little kiddos on a road trip across the country and see all the great things that this country has to offer. It terrifies me to think of it now because my youngest is 3. But I hope within the next, 5 or 6 years that we'll be able to pile in and really enjoy ourselves learning about this magnificent country that we live in.
Question number 4. So it's tornado season. Kristen, Jeremy, when the siren starts blaring, are you heading for the basement, or are you going right out to the front yard to watch?
I'm yelling at my husband to get the kids to the basement, and then I'm looking out the window, or vice versa, right?
Unfortunately, we do not have a basement. We are on a slab, but we have a very Harry Potter-esque understairs storage area where we do have a mattress that my 4-year-old son was sleeping on when our sirens went off at midnight last week. So we're typically huddled somewhere in or near that understairs closet.
In the Dursley residence.
That's right. That's right. See, unfortunately for us, I can't remember the last time a tornado went through during the day, so we can't see anything anyway.
So that'll do it. Jeremy Sukola, Kristen Blankenship, thank you very much for such entertaining answers to the 4 questions and for your knowledge on fluoropolymer top coats.
Thank you, Toby.
Yes, as always, Toby. Thank you.